Mike Abrahamson with Mestek, and today we're here to talk to you about typical maintenance limit faults on our KN series product. The purpose of this video is just to basically discuss the tripping of various limits on the KN series product and how we reset those. Very basic understanding of the controls, their operation, functionality, and purpose. Here in front of me we have our KN 16 series boiler. This is the second generation of our KN series product line. As you can see, the aesthetics have changed slightly on the boiler from our legacy products, our KN 6, 10, and 20. But really the control scheme and the principle of design is the same on our redesigned boilers or our new series products as they are on the old legacy products. You will see eventually the KN 6, 10, and 20 go to this control box design. Common limit failures on any commercial boiler, whether it be the KN series or any of our competitor series products, are pretty much standard in the industry. We have what they call limits, protection devices on any boiler that's out there to provide us shutdown of operation in a dangerous situation. And today we're going to go through the most common limit faults that you'll see on your boiler over the course of their lifetime and how we reset those and address them. If we move around to the left-hand side of the unit, you can see along the top of the castings we have a series of gauges, air vent assembly, low water cutoff assembly. These are mechanical devices that play no role electrically on the boiler. But what we do have along the top is what they call a manual reset high limit. This is a safety device that protects the boiler from overheating. This is basically your last line of defense if the boiler is in a runaway condition. This device will trip on its temperature set point and require a manual reset on this red button if this particular device trips. It's usually an indication that we've lost flow in our system, and the residual heat that is in the cast iron boiler will cause the temperature of the water to migrate up and trip this limit device. By resetting this button, once our temperature has dropped, it should allow the boiler to go back into operation. If we see continual trips on this device, our recommendation would be to call in a service contractor to take a closer look at the system operation. 2 ports down from this device is what they call your low water cutoff probe. This probe is attached to an electronic device on the front of the boiler. On this particular model, it's located right underneath your control cabinet. So if we had a leak somewhere in the system and our water level in the boiler drops below, about 2 inches below this probe point, we're going to trip this boiler off on a low water condition. We have to, again, manually reset the device in order for the boiler to try and operate again. The manual reset will not reset on the low water cutoff unless our water level is back up above the probe at the top of the port. The last device that I want to show you along the top of the boiler is what they call the boiler flow switch. This device is a paddle type switch which basically proves that our pump is in operation, providing flow through the boiler. If this device is not made, it will not allow the boiler to fire. The boiler will never start. You will get a display on the front screen that says flow switch. And until we have enough water flow, enough gallons per minute circulating through this boiler and out to our system, this device will remain open, not allowing operation. Once we have enough gallons per minute, this device closes, allows us to go through our trial for ignition period and into operation. Again, it's just a paddle switch that proves flow operation prior to firing the boiler. And that is located as standard right on the outlet nipple or the supply nipple going out to your system. If we move back towards the front of the boiler and we take a closer look at our control cabinet, you can see, as we noted before, our low water cutoff mounted along the top control panel. That low water cutoff also provides us a test button and a manual reset button. So at any time during the boiler's operation, if we wanted to test that device, we would simply press this button, simulating a low water condition. By hitting our manual reset button, we can basically reset that control if our water level is up above the probe and allow the boiler to come back into operation. The other devices that we see inside this control cabinet, the other safety devices that we have here, one is our low gas pressure switch. This is standard on all KN models. and this prevents us from opening the gas valve in a low gas pressure situation. On our KN 610s and 20s, this device is set at 2 inches of water column, so we need a minimum of 2 inches of gas pressure in order to prove this switch and allow us to go into a trial for ignition. On our KN 16, 26, and 30, it's a 3-inch set point on this switch. If for some reason we have a fault and we do not have enough gas pressure going to the gas valve on this boiler, this device will fault and go into a manual reset condition. You will physically see right on the front display low gas pressure, so you know what device to look for, and then we reset the button that's located on the top of the switch. You don't even need to remove the cover. You just press down on the plastic cover to the red reset switch, and it will reset your low gas pressure reading and allow you to go into a trial for ignition. 3 devices located at the center of the control box are all your blower-proof devices. The white switch located here, they call it the HUBA switch. This is our blower-proof switch. This tells the heat net control and our Honeywell ignition control that we've got blower operation and we're prepared to fire. If this device does not prove, we will not go through a trial for ignition. We also have 2 other pressure switches that are normally closed on this unit. One is a block combustion chamber and one is what they call a block condensate switch. Those are normally closed switches, and the only time we would ever see these switches open would be if we had some sort of restriction in the unit that wasn't allowing us to put enough airflow through the unit. Where the HUBA switch, the blower-proof switch, is a normally open switch that closes upon fan operation. And then the last device in the control cabinet that we're going to concentrate on is what they call our Honeywell 7800 series control. This particular unit is the 7895C, which is standard on all the KN products. And this is basically what they consider our primary control or our burner control. This is the safety device that allows us to see a flame, whether it be pilot or main flame in the boiler, and shut us down if we have a loss of flame during operation. Many things have to happen before we go through a trial for ignition on this particular boiler. On an initial call for heat, we have to start a pump. The pump has to close our flow-proof switch, indicating that we have proper flow. On many applications, we have what they call a combustion air damper, which has to open and prove a end switch on the combustion air damper before we go through a trial for ignition. Your low water cutoff and your manual reset high limit both have to be made, both have to be basically closed in order for the boiler to go through a trial for ignition, and we have to have proper gas pressure going to the gas valve on the boiler, again, for us to go through a trial for ignition. The first fault that we're going to generate on this KN Series 16 is a flow-proof switch fault. In order for the boiler to operate properly and to go through a trial for ignition period, we have to prove that there's water flow going through the piece of equipment. If our pump is not working properly, or if we've got some situation where we're airbound, and we're not moving water through the particular piece of equipment, that flow switch is not going to make it. It's going to generate a fault. What the flow switch will do is, if for some reason it's not made on an initial call for heat, we'll have what they call a flow wait period. So we'll have a display that says flow wait, and the control is basically waiting for a period of 10 minutes to look back across that flow switch to see if we've established flow in that period of time. Eventually, after an hour's period of time of not seeing that flow switch closed, we're going to see a flow switch fault on the boiler. And I'd like to generate those faults for you so you guys can see what the display looks like when that takes place. So we're going to provide a call for heat on the boiler by throwing our low fire and calibrate switch down at the bottom of our heat net control. We can simulate a call for heat on the boiler. And you can see the first thing that it's trying to do is to pre-purge its fan and go through a trial for ignition. The reason that it's doing this is because our pump is in operation. We're actually flowing water through the piece of equipment. However, if I were to stop flow on the boiler, basically by turning my circulator off, we're going to generate an error on the front of our control screen. That error says flow wait. So it's not allowing the boiler to operate at this point. It's waiting for prove of that flow switch. Eventually, when it does not prove, you're going to see water flow switch. Your water flow switch is tripped. Very understandable fault. pointing you in the right direction. The water flow switch is not made, indicating that we've got an issue with our pumping on the system, or the possibility that we've got an air-bound system. When it's generating any of these faults, you can hear the beep, the audible noise in the background. If we want to silence that, you're just holding your back and your select keys down at the same time. That will silence that beep so you can think about how to troubleshoot the boiler. But again, fault is water flow switch. We know it's a very simple fault on the boiler. It just indicates that we're not putting enough GPM across that flow switch. We can clear that fault simply by making sure that our circulator or our system pump is in operation. If we reset our pump and we're positive that we've got flow through the system and we continue to generate this fault, then it typically means we've got some sort of air in the system, and you may want to call in a service agent to take a look and possibly bleed the system. In order to clear the fault, we're turning the toggle switch, the on-off switch on the boiler, on and off, basically resetting the heat net control platform. We've already established flow again with our system circulator pump, so all we're doing is resetting power. Now it should go through a trial for ignition because it has pump operation. And as you can hear, your fan is starting. That's indicating that we have proof on the boiler and that we've allowed it to move to the next basic point in our trial for ignition period, which is blower operation and piloted ignition. So again, when addressing a flow switch fault on the boiler, it typically means that your pump is not operating in your system, or we've got some sort of a restriction in the system that's not allowing proper flow through the boiler. That could be an air-bound system, it could be a series of zone valves or a motorized valve that's not opening, allowing us full gallons per minute of flow through the unit. Again, once we verify that pump operation is working and that we've got flow through our zones in our system, we should be able to prove that flow switch, reset your control, and allow the boiler to go back into operation. The next fault that we're going to generate is a low water cutoff fault. This would be simulating a condition where we've got some sort of leak in the system, whether it be at one of our receptacles or our termination devices or our underground return pipes possibly. Something that might not be visual to the naked eye as far as in the boiler room, but could present a problem in the system. In a low water condition, this device is going to trip and not allow our boilers to fire. We cannot reset this device unless we have proper water level in the boiler. So again, we're going to put the unit into operation, provide a call for heat. Prior to it starting its fan, it's looking across that flow proof switch, verifying that we've got proper flow through the boiler before it goes through its trial for ignition. In this event, we have proper flow, our fan has started, we'll go through a 10-second pre-purge on that fan and then go through our trial for ignition period on our pilot. Pilot ignited. We are now in main valve running at our minimum modulation on the boiler. Currently it's set to 4-to-1 turn down, so we're running about 25% of modulation in order to ignite the boiler, 20% of modulation once that pilot has been established and we drop to our lowest modulation rate. So right now we're just cruising along at 20%. We're going to generate a low water cutoff fault. Very easy for us to generate that. Something that you can test in your boiler room as well and should be part of the normal maintenance process, at least annually checking the low water cutoff device. You can see we have a manual reset button and a test button located on the front screen. In order to generate a fault, we're simply going to press the test button on the front display, and we're going to hold that down for a period of 5 seconds. That will create a fault of a low water condition on the boiler. And as you can see in clear English, it does state it right on the front display, low water cutoff. So again, pointing you in the right direction on what the fault is. Our fault will remain on the front display screen and not allow for operation, and will continue to say low water cutoff until somebody has reset the device. Again, if you see this particular failure mode, it's usually an indication that we've got a low water condition in the boiler. It could also be due to air. If we had a large air bubble or a slug of air that went by that low water cutoff probe device, it could simulate a low water condition and cause the control to trip. So all we're going to do on this is hit our manual reset device. Again, we're going to hold this button down for about 5 seconds to reset that low water cutoff control. At that point, we should have continuous operation on the boiler. If we continue to trip on low water cutoffs after we've reset it the first time, then obviously it's a system issue. We've got a problem with either air in the system or we've got leaking pipes, a true low water condition. Now that we've established gas pressure to the valve, we should successfully complete a trial for ignition period on the boiler. The next fault that we're going to develop, now the unit is back in operation, we cleared our low gas pressure fault, and the unit is running at low fire or 20% of its rated input. We're going to simulate a blower failure on the unit by interrupting our pressure switch circuit, or our fan-proof switch circuit. You can see that almost instantly went into fault. As soon as we lost contact with that blower switch, it shut the unit down. Now it's going to go into a post-purge, basically purging out any of the gases that may be in the unit. Will again go through its pre-purge, trying to prove that blower. It's still initiating the blower, and it's trying to prove that switch. You can see the control will just sit at pre-purge, and you'll never go for your trial for ignition period. This is a timed event on your blower post and pre-purge. This will actually pre-purge for a period, I believe, of up to 1 hour before it and we'll continually check across that switch to see if we've made our pressure switch. Anytime we have an interruption in this circuit, it's an indication that we've got some sort of restriction on the exhaust of the boiler, perhaps a prevailing wind, perhaps a bee's nest or a squirrel or some type of critter has gotten in there and built a nest in your exhaust, creating a blockage, not allowing the fan to come up to full speed. You could have the same thing on the air intake of the boiler as well, something restricting the air intake. A child has thrown a ball or something into the air intake, creating a restriction. It's in the heart of winter and we have a lot of moisture in our flue gas, and we've frozen up the terminations on either the air intake or the exhaust of the boiler. Will cause this pressure switch not to make and not allow us to go into a trial for ignition. So when we have a blower fault on the unit, if we can physically hear the fan turning in the boiler, then we know that the restriction is external to the piece of equipment in most cases. It's going to be the air intake or the exhaust that's blocked. Once that obstruction is removed, we should go back into reliable operation. I'm going to reattach my wire to the pressure switch. And again, as that heat net control is continually monitoring, get that on. So basically we've timed out now. We've timed out on the blower. It's not allowing reinitiation. We've ran that blower for a period of 1 minute, excuse me. We should probably go back. So again, with our air switch faulted, we pull the wire off of our blower proof switch. With the air switch faulted, your blower will continue to run for a period of 1 minute, continually looking at the position of this switch, looking for a close contact in order to go through a trial for ignition. If at the end of our 1 minute blower operation time, we still see no continuity or no closed circuit through this switch, then the boiler will go into a lockout condition, and you can see on the front of this display, it indicates fault, air switch, blower. So again, these three devices, any of these three devices trip, it indicates that we have improved fan operation on the unit and it's not allowing it to go through a trial for ignition. I'm going to reconnect the pressure switch. And again, when troubleshooting this would be an indication of a restriction on both the air intake or the exhaust. Either or could cause the blower switch to trip. A lack of voltage or a brownout condition may not provide enough voltage for the fan to operate at full RPM. That could be an issue as well. The two switches down below, again, are normally closed switches. These switches are always made. The only time that either of these switches would open up or you wouldn't have continuity across the terminals on these two switches would be if we had some sort of restriction internal to the boiler, like a section that was blocked or a condensate drain line that wasn't draining properly and has built up liquid in the bottom of the unit. The only way to clear that would be to basically make sure that that boiler is drained out properly so that we have proper flow of our condensate, and verify that you've got an air intake and exhaust that are open and readily able to pull in and exhaust air. Again, to clear this fault, we need to physically reset the boiler. We need to reset the on-off switch located on the front of the boiler. There's no time requirement for that reset, simply an on and off of the switch. Again, we say heat wait. We improved flow operation, allowing us to go into pre-purge. Our fan starts, pre-purges for 10 seconds. Annual maintenance on the KN product requires us to inspect and change our filter on an annual basis. In applications where there's more of a dirty medium, possibly pulling in outside air from a dusty environment, or pulling in from an enclosed room with a combustion air damper, possibly a dirty environment, requires us to clean this filter. As this filter gets restricted, we could actually see the input rate drop off on the boiler, or the BTUs that the boiler is producing drop off on the boilers. Very simple process for cleaning this filter. We can just run it through under cold water and clean the filter. This will allow any loose debris in the filter medium to drain down your drain and to allow you proper operation on the boiler. Your next step is going to be at the lower portion of the boiler. We have what they call a base pan. This base pan is designed to catch any condensate that's leaving our cast iron sections. That moisture drips into this pan and may bring with it debris or small particles of cast iron that have broken down off of the heat exchanger block and into the pan. This should be serviced annually. We have a series of 6 7/16 nuts that hold this cover on with a gasket behind it. We're going to remove those nuts, pull the cover off the base pan assembly, and remove our gasket. Once we remove our plate and gasket, you'll be able to get the nozzle of your shop vac into the bottom of the base pan of the boiler, and this should be vacuumed out as part of your normal maintenance cleaning procedure. In fully condensing applications, we may want to do this semi-annually every 6 months, clean out the pan, but in most applications that are combination condensing, non-condensing, depending on the time of the year, typically one cleaning a year is sufficient. Once that's vacuumed out, very simple assembly process. We just put our gasket back on again and reattach our cover.